You realize now you are going back to each and every phase once again. In define phase, you learned the new tool called QFT, quality function deployment, and in the measure phase, you have you are going deeper into the gauge R&R, how to read the graphs, and the AAA, which is attribute agreement analysis, kappa analysis, and now one more tool, PPPPK. So that means you can now be laser focused on what you are doing, in an improvement project. So before getting into PPPPK, tell me what is CPCPK? You have studied, am I right? What is CPCPK?
CP is the process performance.
CP is the process
capability. Yeah.
Process capability. Very good. Yes, come on, please, all of you. You hereafter, you all have to be very, very active, and then, we should be able to talk about every tool and every the phase. So now CP is somebody told process capability. What else you know about CPCPK? What is that you have understood about CPCPK?
CPK should be 1.67.
Very good. CPK should be
potential. CP is potential.
CP is potential. So before that, Raghavendra gave a solid point. CPK should be 1.67 for all critical process.
Yes, sir.
For non-critical process, it should be 1.33.
Yes, sir.
Right? It should be 1.33 for non-critical process and should be 1.67 for critical processes. Why there are two metrics, one CP and another one CPK? Why there are two metrics required? Why don't you manage with one?
CP is an individual one process, one batch process.
Potential of
With multiple batches, then CPK is required. For seeing the variance.
CP is for individual, sir. And for CPK, we'll take average.
Oh, so CPK you take average, then for CP?
For individual, means individually we'll check.
No,
sir.
Statistically,
tolerance by
yes.
sigma is nothing but CP.
See, statistically, your problem will reflect in two measures. One is variation, another one is central tendency. Am I correct?
Yes, sir.
You are not hitting the target. There could be two reasons. One is you are not holding the gun in the correct position. You are not holding the gun in the correct position, isn't it? If you don't hold it in the correct position, let us say you are holding it in this manner towards the sky, will you be able to hit the target?
No.
No. So whether you are holding your process in the right place or not, that will reflect in average. That will reflect in average. Even if you hold your gun correctly, still you can miss the target. Am I correct or not? Even if you position your process at the right place, if you allow the process variation to increase, then also failure will happen. Then also rejection will happen. So there are two things you need to control. One is central tendency. Another one is variation. If the variation is under control, if the central tendency is on the target, you are going to hit the target consistently well. Everything you produce will always be within the specification. So whether both are happening or not, we are checking using two matrices. One is CP, another one is CPK. If you look at the formula of CP, what is the formula of CP? USL minus LSL divided by 6 sigma. Only sigma is participating in your equation, no X bar. What is X bar? Process average. But what is sigma? Process variation. So CP works only on variation. All of you understand? CP works only on variation. All the problems due to the increase in the variation, your CP can monitor. Do you understand, all of you? If CP is if CP is more, that means variation is less. If your CP is going down, it's an indication that variation is increasing. If the variation increases some point of time, the control limit can go beyond specification limit. If the control limit goes beyond specification limit, then the rejections you will start observing. So hope all of you know all these things. Have you studied or not CPCPK, all of you?
I studied once, sir. Still,
Yeah, if you want to study the second time, then you have to again join the course second time. You should be able to observe, but recording you can go through multiple times. All right, anyway, let me try my best. So CP, the formula is, okay, let me show you the formulas of CPCPK also, and then come to your BPPK. So can you all see my screen?
Yes, sir.
I'm recalling CPCPK, but I'm not happy with your answers. It was not crystal clear. You understood, but then still, whether you could use it practically, and there has to be clarity in your understanding. So this is the formula for CP: USL minus LSL divided by sigma. Here only sigma is coming into picture. But if you come to the CPK, minimum of CP upper or CP lower, can you see X bar also participating?
Yes, sir.
X bar also participating in addition to sigma. So that is why CPK is a better measure of capability than CP. CP is called only potential measure, but CPK gives the real picture. Because it not only checks your variation, it also checks your central tendency, right? So for any process to remain capable, CPK should be more than 1.67. Simple thumb rule. Always CPK will be smaller than CP. CPK will be smaller than CP. So look at the CPK first. If CPK itself is more than 1.67, take it granted, CP will also be more than 1.67. Your process will be capable in terms of variation, in terms of central tendency. If CP and CPK are same, it means your process is centered properly. Your process is centered on the target. If CP and CPK are different, let us say CPK is 0.8, CP is 1.6. They are different value. It means your process is off-centered, right? And now tell me, is that process centered properly?
Yes.
Sir.
Now if you measure CP or CPK, both will give same value.
Yes.
Whenever you get CP, CPK same value, please understand your process is centered on the target, right? CP is 1.67. When I calculate CPK, CPK will also come to be 1.67. It is simply because process is centered on the target. And now your process has become wider. Can you see the control limit going beyond specification limit?
Yes, sir.
yes, yes.
Under
Yes,
the
sir.
situation, when you calculate CP, CP will go below 1. CP will go below 1. That means, your process is not capable
Not
in this case. Though CP equal to 1 means process is just capable, industry requirement is minimum 1.33 for non-critical process and 1.67 for critical process. And see here, process is shifted. You are calculating CP. Look at the CP value. CP means USL minus LSL by 6 sigma, isn't it?
Yes, sir.
Look at the answer, 1.67. Does it mean your process is capable? No.
No.
Though CP is 1.67, our control limit has gone beyond specification. There are rejections happening here. So CP is not the measure of capability. CP is only the measure of the consistency. Please understand. CP is only the measure of the consistency. It only measures variation, right? If you want to know the real capability, you need CPK. So that is why, where we have this formula, CPK. CPK will compare half of the specification to half of the tolerance, half of the customer tolerance to half of the process tolerance. Half of the process tolerance means 3 sigma. Half of the customer tolerance means distance between USL and center. Similarly, distance between LSL and center. So blue bar by 3 sigma, green bar by 3 sigma. are called the CP upper and CP lower. And whichever is, if your process is moving to the right, what will happen? Blue bar will start reducing. Blue bar will reduce. That means CP upper will go down. Whichever is going down, that will be the value of CPK. See here, minimum of. Because whichever side my capability I am losing, I need to capture that information so that I know about real capability, right? So that's how CPK is designed. And now see here, process has shifted. In this condition, what is the CPK? 1.67. Process is shifted. Can you notice the blue bar reducing the size? All of you?
Yes, sir.
Now it is going down. So as a result, CP upper is going down. As a result, CPK becomes 0.833. A process with a capability of 1.67 has lost its capability, and CPK become 0.833. So process shifting will get captured by the CPK. So ideal condition, the required condition is CP must be equal to CPK, and moreover CPK must be more than 1.67. If these conditions are satisfied, your process is definitely capable. If CP equal to CPK, if it is yes, what do you understand? Process average is equal to customer target. If CP is not equal to CPK, what do you understand? Process is shifted. Now the remedy is move the process towards target. Move the process mean towards target. If CP is more than 1.67, what is the conclusion? Process outputs are consistent. I am not saying capable. Process outputs are consistent. It can be consistently good. It can be consistently bad also. But when CPK is more than 1.67, process outputs are not only consistent, but also good. This situation is called capability. Hope all of you understand.
Yes, sir.
And now all these things, I'm not going to get into the detail. Now coming to PPPK. Now there are two players I'm showing. Right, two players. Both are the Indian team batsmen. And this is Shikhar Dhawan, and then this is Ganguly. And tell me, now you can have one member in your team. Whom you would like to have?
Dhawan.
And you are going to play an important match. Your team is going to play an important match. Would you like to play with Shikhar Dhawan in your team or Saurav Ganguly?
Saurav Ganguly. Shikhar Dhawan.
Then all of you, please choose your choice. I could see from here from Sunil and Sundar. How about others? You don't want to play?
Dhawan.
Saurav Ganguly, sir.
Saurav.
You are a fan of Saurav Ganguly. I know. You are from Hyderabad, huh? No. Okay, Kolkata, Saurav Ganguly, Kolkata. Yeah. See, if you actually, since you like Saurav Ganguly, if you have him in your team, do you think he can hit century tomorrow?
No, sir.
Right. No, Saurav Ganguly, I agree. He is a good batsman. But can he play now?
No.
He has become old, isn't it? He got
No.
retired. Then why did you want to have him in your team? Now, who
Experience.
can do the job for you now?
Dhawan.
Dhawan. If there is a choice, Dhawan is the best option. Because he is a performer as on date. Both are capable, but who can perform? Ganguly or Dhawan?
If it's matter
Dhawan.
of age on date, sir, obviously it will be Dhawan. But if
Yeah.
you'll compare both, obviously Saurav Ganguly is more experienced and all those things. So we have selected to Saurav Ganguly. But
No,
if
experience is,
any match is there, then definitely Dhawan will be the preference.
okay. Experience is okay. Experience is okay. But for me, see, tell me, your experience is important or performance is important?
Performance.
So CPCPK talks about capability. PPPK will talk about performance. Which is important to you? Performance. Performance is what your customer will feel. Capability is what you have. Performance is what you actually give. We know many things about Six Sigma, but what is that we are giving to you in the training that matters to you? Am I correct or not?
Yes, sir.
So CPCPK is your short-term capability, but PPPK or your long-term capability, PPPK are your performance indices. PPK are called performance indices. So performance is more important than capability.
Capability.
But formula wise, all are same. Both are same. Look at the formula. USL minus LSL by 6 sigma. USL minus LSL by 6 sigma. And similarly for PP. PP upper and PP lower. PP upper, PP lower. Formula wise same. Then what is the difference? The difference is in the sigma. The difference is in the sigma. How do you calculate sigma? See, in the morning we talked about gauge R&R. For calculating repeatability, we took one sigma. For calculating reproducibility, we took another sigma. Then we combined it. So there are different ways you can actually calculate sigma. Whenever you have a data, you can actually calculate 4 types of standard deviation. I don't want to confuse all of you with all the 4. I'll only help you understand 2 standard deviation. One is called within standard deviation. Another one is called overall standard deviation. One is called within standard deviation. Another one is called overall standard deviation. If you understand and if you use within standard deviation, then what you are getting is Cpcpk. If you use overall standard deviation, then what you are getting will be PPPK. That is the only difference. Sigma is here. If you use within, what will you get? Cpcpk. If you use overall, what will you get? PPPK. So let us see that. So what is PPPK and when to use it, and understanding the standard deviation. See, 4 types of standard deviation: sigma within, sigma between, sigma combined, sigma overall. At least try to understand 2, sigma within and sigma overall, and then we will see a case study with the calculation. Look here, a process is today operating in this manner, like this dotted line. Can you see?
Yes, sir.
Now it looks taller, it looks narrower. But when I run it for a longer time, the process slowly becomes in this manner. Can you understand the process, slowly losing its capability? Yes or no?
Yes, sir.
In short term, process is performing to its capability. But in a long term, process, is losing its capability. Now in the long term, when you again calculate the, capability of the process, that will be called the PPPK. And if you want to get an estimate of the PPPK, or if you want to get an estimate of the long-term performance, you can use the data collected in short term in a particular way so that you can get an estimate of your long-term performance. And now capability depends on variation as well as position of the center. What is position of the center? X bar. What is variation? Your sigma. How are you going to use the X bar and sigma? What X bar, what sigma? That will tell you whether you are measuring short-term capability or long-term capability. So while measuring the short-term capability, there is sigma within, there is sigma between. You can combine the 2 and get the sigma combined. Now out of the 3 options, if you use the within sigma, then what you are calculating is within capability. What you are calculating is within capability. And I am leaving this for now, but I would like to come back to you once you are ready, right? Coming on to the other side, long term. Use the long term standard deviation. Now you are getting overall capability. Overall capability are given the symbol PPPK. And let us see this with the case study. Sometimes the short term capability CPCPK are also called as potential measures. And long-term capability are called as the actual measures or the performance indices, right? Left side is capability, right side is performance. And formula for PP and PPK. PP and PPK. Look at the formula. Are you able to notice any difference here? Any difference from CpCpk to PPPK? Anybody? Can anybody simplify my job?
Sir, 3 sigma is there, sir. In PPPK.
Yes, in CP also 3 sigma, PP also 3 sigma. To differentiate, I have added overall here. I have suffixed, the overall here. And again, look at the formula here. Generally, for calculating the sigma, we go for a formula called R bar by D2. We go for a formula called R bar by D2. R bar by D2 is within standard deviation. But now I am using the normal formula of the standard deviation, which is called, the overall standard deviation. Whenever your process is not in statistical control, it is not advisable to conduct any capability study. If you have not attended the training program, there is no point of conducting you the certification exam. Am I correct or not? You have not attended the training program. And what is the point of assessing? Similarly, if your process is not even in a state of statistical control, better avoid conducting the capability study. It is going to give no meaning. But if at all you are forced, then just look at PPPK, not other things. At least you get to know a closer picture. On the other hand, your process has come to a state of statistical control. Now you are ready. Now you can conduct the capability study. Try to understand what are you capable of. Try to understand what is that your customer is going to get from you. And if you are looking at your short-term capability, use CPCPK. If you want to get an estimate of your long-term performance, then use PPPK. All of you understand when you should conduct the capability study? Yes or no? Yes or no? Do you understand, all of you?
Yes, sir.
So point is, you can
Yes, sir.
conduct the capability study if the process is under statistical control. How do you know whether the process is under statistical control or not? Plot a control chart. If you get all the points inside the control limit, process is under control. Process is under control. If any points are outside, process is out of control. Point outside the control limit are called outliers. If there are outliers, conducting the capability study will not give the real picture, right? So you must first fix them. And now there is a small problem we are going to discuss now. See here, coating thickness. Coating thickness is important to your customer. And the requirement is 50 mm or something, or 50 mm. So now customer has given a tolerance also, plus or minus 3, right? No, is lenient. So 47 is the LSL, 53 is the USL, and these are the observation. How many observations are here? Nearly. How many observations? Nearly 60. Am I right? See here, roll number 1, there are 3 readings. Roll number 2, there are 3 readings. How many rolls are here? 20 rolls. 20 rolls. Every roll, you have taken 3 samples. So 20 into 3, 60 samples. Each roll, when you are using, because the raw material is coming in rolls. So every time you change the roll, you have the habit of collecting 3 samples, right? Always you are taking samples at a time, 3 samples. This is called a subgroup. What is the subgroup size? What is the subgroup size? 3. Subgroup size is 3. Totally, how many subgroups you are seeing here?
20.
Come on, please respond. 20 subgroups. 20 subgroups, and every subgroup you have 3 samples. So totally 60 data points you have. Now, how are you going to use this data? That is going to talk about whether you are measuring CPCPK or PPPK. And now some calculations I am going to show. I purposely removed certain things, certain rows to minimize the confusions, right? First row, number of subgroups is equal to 25. All of you understand? Oh, is it 25 or 20?
20, sir.
See, I'm sorry, 25 is there. See here, 25. 25 roles. So totally how many data points?
75.
75. I'm sorry. Not just 20, 25 subgroup. So 75 data point. So total number of subgroups is 25. Hope everyone is clear with first row.
Yes, sir.
Right. Subgroup size is 3. Understood. All right. Total number of data, 25 into 3, 75. Now, within the subgroup, you will see some variation. Possible or not? Within the subgroup means, let me show you. Subgroup number 1. Are you seeing some variation?
Yeah.
This is called within batch variation. If the within batch variation is minimum, what does it mean? All the products you produced from roll number 1 are more or less same. The variation is very minor. Do you understand, all of you? That is the purpose of monitoring within batch variation. Using roll number 1, you might have produced 3,000 pieces. Out of the 3,000 pieces, you checked only 3 and you found the variation as very minimum. That means all the 3,000 pieces produced using roll number 1. You can take a call by looking at the variation here. If the variation is less, if the sample is acceptable, the population of 300 is also acceptable. All of you understand?
Yes, sir.
Right. So this is why we are monitoring within batch variation. Roll number 1, this is the within batch. Roll number 2, can you see the roll number 2 within batch variation? All of you?
Yes, sir.
Which is more? Roll number 1 variation is more, or roll number 2 variation is more?
Two
Can you make
variation
some
more.
guess?
Two
Two variation is more. That means within the roll number, subgroup number 2, the variation is increasing. If you allow the within batch variation to increase, there is a chance that all 3,000 pieces produced from roll number 2 can get rejected at your customer site. Do you understand why we are controlling the within batch variation?
Yes.
I do not know how many of you are understanding. Your yes is
But customer has given the specification 3 now, sir. Plus or minus
yeah,
3.
customer has given the specification. Let us say 50 plus or minus 3. Let me change the specification now just to manage your question. 50 plus or minus 0.3.
Okay. Then
Isn't it?
two will
So,
reject.
yeah, if there is a very wider tolerance, we don't have to do anything. We are not required in the company. The machine operator himself will run the business. Company doesn't require, like data expert and all. But now the tolerances are too small. We are required 50 plus or minus 0.3. So within batch variation, if you don't monitor, if you don't control, there is a chance that the entire lot might go wrong. Hope all of you agree with me.
Yes, sir. Total 3,000 will get.
Very good. Now, when I monitor the within batch variation, here within batch variation is now small and batch number 2 is more. Let me come here, last subgroup number 25. Look at the variation within batch variation. How is it?
Variation is less,
Small?
but it is in
Very
higher
less.
side. Yes, sir.
Very less. But all the unit has
Will get
moved from 50 to 51. If you only keep an eye on the within batch variation, even if the within batch variation is under control, still the entire lot can get rejected. Do you understand? If the tolerance is 50 plus or minus 0.3 or 0.5, all the 3,000 pieces you produced using roll number 5 will get rejected. That is why, in addition to the within batch variation, you should also control the between batch variation. Do you understand?
Yes,
In
sir.
addition
Yes, sir,
to the repeatability, we also discussed about reproducibility today morning. Something similar to that. Within
Yes,
batch
sir.
variation is under control. Keep an additional eye on the between batch. Between batch means what is the average of your first subgroup? What is the average of the second subgroup? What is the average of the third subgroup? The average should also be close to each other. If the average is, moving away, what do you understand? There is a chance that entire lot might get rejected, right? So that is why there are different types of standard deviation we require. Within standard deviation, between standard deviation, and there is one more thing called overall standard deviation. Overall standard deviation concept is much easier. So I would like to educate you on calculating within batch variation. In order to calculate the within batch variation, you only require range of each subgroup. How many subgroup you have? 25. So you will have 25 ranges. Can you see here? R1, R2 up to R25. Now for every subgroup, calculate the range. 25 ranges are there. Now calculate the R bar. R bar is nothing but average of all the 25 ranges. Add all the 25 ranges, divide by 25. That's how you get R bar. Now you can convert the range into standard deviation using a statistical formula R bar by D2. R bar by D2. Because range is a measure of variation, standard deviation is a measure of variation, variance is also a measure of variation. Standard deviation can be converted into variance. Variance can be converted into standard deviation. Similarly, range can be converted into standard deviation. For that, you require this formula R bar by D2, where D2 is a statistical constant which depends on your subgroup size. Here, the subgroup size is 3. For a subgroup size of 3, the D2 is 1.693, which is available in a table, control chart constant, 1.693, using which I got sigma within to be 0.4139. Hope all of you understand how the sigma within is calculated. All of you please confirm, have you understood how to calculate sigma within? Confirmation.
Yes, sir. That D2 from where came, sir?
You want to see D2? This is the table. And see here, D2. What is the subgroup size? 3. What is the D2?
1.693.
Yes.
Is it free, sir? It is fixed as per the chart, right?
It's a statistical constant that is available. The table is available. Generally, no, subgroup size goes maximum of 25. And for all 25 possibilities, D2 is available.
Okay, fine, sir.
Clear?
Got it.
Right. Now, then this column also not required. Now come here. Overall variation. Overall variation means how many data points you have right now?
25.
75. Use all the 75 data and calculate the standard deviation. X bar means average of the 75. N is 75. Now you get sigma to be 0.8384. If this overall standard deviation is far away from within standard deviation, please understand there is a lot of problems happening. There is a lot of problems happening, right? And now the overall standard deviation is available. Now you can decide to use this standard deviation or this standard deviation. Both are coming from your company only. If I use this standard deviation, I get, the Cpcpk. Just give me 1 minute. I'll show you. Just. I removed one column. Yes, I'm coming again. Just a second. So you can see my slide once again. And now all these columns also filled up, but still you don't have to focus on, the other calculation. But look at this column. If I use the CP of 0.4139, look at my Cpcpk value. How much it is coming? 2.46, 2.37. It looks as if my process is extremely capable. But there are a lot of complaints from my customer. There are a lot of complaints from my customer because I controlled only within batch variation and failed to control the between batch variation, failed to control the overall variation. For your long-term success, you should not only control within batch variation, but also control between batch variation so that the overall variation will also be under control. For the same set of data, when I calculate Cpcpk, it looks extremely capable, but PPPPK, you can see and you can understand 1.19 and 1.15. Which is your real capability? Which is your performance? Which is that your customer will experience from your company? PPPPK or Cpcpk?
Cpcpk.
According to the Cpcpk, we studied 2.46, 2.37, extremely high values, more than 6 sigma. So PPPPK is the long-term capability, and we should always look for a higher PPPPK value, not just Cpcpk value. See, slowly, don't think that CPCPK, then you studied CPCPK and that is becoming useless now. Yes, because now we change our thinking from short term to long term. Because in a long term, deterioration can happen, wear and tear possible. The supplier incoming material quality can change. There are many factors that can come and play in a long term. So that is why we should focus on the long term capability. Right? This is the table. And now look at my process. Now tell me, is this process under statistical control?
Below
Is this
one
process
is
under statistical control or out of control?
first one is out of control.
So many points are outside the
Out of
control
control.
limit. It is definitely out of control.
Out of control.
And your customer is expecting you to give a measure of capability. Technically, strictly speaking, you are not eligible to conduct the capability study. But your customer wants to see your capability. Now, which metric you would like to use? Will you use CPCPK or PPPPK?
CPPK.
Because that can give at least a closer picture of what is going to happen, isn't it? Right?
Yes,
But
sir.
this subject is always a confusion in majority of the companies. If you gain proper clarity, and definitely you will gain a lot of respect. You will definitely stand out.
Live examples, please, sir.
This is live example. Whatever we are discussing is a live example. Anyway, you can see every case is an example. All that required is a data. Now thickness is we have discussed. It can be surface finish. It can be your test mark. It can be the delivery time, which is critical to your process, right? So the point here is better avoid conducting any capability study because you have a problem in gaining the control itself. If the students are not even coming to your class, will you still think of preparing a good lecture and good presentation? Students are not coming to your class, gentlemen. Do something and get your students sit in the class. Your process is completely out of control. Can you run projects to fix all these out of control points? That is the requirement right now. That's the requirement. Each point going out of control limit is definitely a serious issue. We need to investigate why the points are that too very frequently. So instead of proceeding with the capability study, and first of all fix all the special causes. But if at all the situation demands, yes, you need to do some study. At least look at PPPK. Don't look at CPCPK because that will give you a completely wrong picture. So please don't look at CPCPK. So the process with the CPCPK looks like this. With the PPPK can look in this manner. Right? What is going to happen in the near future? Yes, that is visible here, not here. And this is the case we discussed. You see here, CPCPK 1, PPPK 1.19, 1.15, 2.46, 2.37. This is generated from Minitab, and we just cross-verified with the manual calculation. So similarly, this is the actual and this is potential. If there is a big difference between CPCPK and PPPK, you have a big role to play in that company. If you call me as a consultant to your company, and if there is a big difference between CPCPK and PPPK, I will realize I have at least 3 years job in your company. Right? Because PPPK approaching CPCPK, it means you are not only good at short term, you are also good at long term, which is possible only if your process and procedures are extremely strong, and even people. Right? If everything is followed diligently, then only CPCPK and PPPK will approach each other. So this is the same case only, and this is the overall standard deviation which we calculated. The other standard deviations. And there is one more case, since you wanted one more example. A manufacturer of cable wire, he want to assess whether the diameter of the cable meets the specification. The cable wire must be 0.55 plus or minus 0.05. Look at the specification, plus or minus 0.05. And to meet the specification, analysts evaluate the capability of the process to ensure it is meeting the customer requirement of a PPK of 1.33. And if the company knows the subject, definitely it will ask for the PPPK, not CPCPK. If your company is speaking CPCPK, you can understand, they have a long way to go in terms of the capability analysis. So PPPK should be used, frequently, because only that can give you the closer picture. So every hour analysts take a subgroup of 5 consecutive cables. That means subgroup size is 5. Subgroup size is 5. And record the diameter. Once the data is ready, you know how to deal with the data and calculate to get the CpCpk as well as the PPPPK. So
Sir, any change of the data points, number of data points for CpCpk and PPPK?
come again, sir. Any?
Change in the number of data points required, like CpCpk is a minimum data points is sufficient, and PPPPK is more data points are required. Like that, when you are saying short term and long term, I am just thinking in this way.
Good question. See, when we are actually collecting a data, and if the data doesn't have any trend or pattern, and no out of control points, then the data is sufficient. When you are plotting it in a control chart, if there are out of control points, then first of all you should fix that out of control point. Number one, why the point has gone outside the control limit. And suppose if everything is inside, suppose if there is a pattern or a trend, the points are continuously going up. And now you are calculating the capability and everything is good. But
Good.
next week, there will be a problem. You know why? There is a trend of the points moving upward. So when you are able to see your data distributed randomly, no pattern, then your data is sufficient for interpretation. Your data is sufficient to predict the future, right? So simply by plotting it in a control chart over a period of time, then you can understand whether the data in your hand is sufficient or not, right? So depending on here, we have collected 25 subgroup, isn't it? So if you plot an X bar R chart, you will have 25 points. If all the 25 points are properly randomly distributed within the control limit, then your data is good enough. You can take conclusions.
Okay. Thank you.
Good. So thank you all. Probably please come on the Wednesday classes where we can discuss little more deeper also, and maybe any special, all of you, if you have any your similar work if you are doing in your company, please bring those matters. Please bring those matters for the discussion. It can be over and above the Wednesday, Thursday class also. Please reach to me through WhatsApp. We can discuss your case so that you will be able to better connect.
Okay.
Thank you.
Thank you.
Thank you. So to Vivek, sir.
Thanks, sir.
Somebody speaking?
Sir?
Yes.
Sir, can you also share, sir, CpCpk calculator, sir?
CpCpk calculator, RK sir has given. No, okay. I will right now upload it in the WhatsApp group.
CpCpk calculator given no in the morning.
Thank you.
No, that is for the GB we gave. Now I will put it, share it in the BB group.